fringe width interference. What is interference? It is a phenomenon of superposition of waves of same wavelength, same frequency, either in phase or having a constant phase difference. Let us see the experiment conducted by Young. The Young's experiment consists of a monochromatic source. What is a monochromatic source? It is a source which sent out light of single wavelength. The light is allowed to pass through a very narrow slit. The set of waves coming out of the slit is allowed to pass through two symmetric slits, so that these two slits act as coherent sources. The light waves coming out of coherent source, which are the two slits, interfere either constructively or destructively and form the interference fringes on the screen, which is kept away from the coherent sources. The intensity distribution of the fringes are shown by the pattern. Here we can see a bright fringe which is of maximum intensity, a dark fringe which is of minimum intensity, and again bright, dark. This way alternate bright and dark fringes are produced on the screen. All the bright fringes are equally bright and all the dark fringes are equally dark. Moreover, these interferent fringes are of equal width. Next, let us see how to get an expression for fringe width. For this, let us consider the monochromatic sources to be S1 and S2. These two sources are separated by a very small distance d, equal to small d, which is in millimeters. Nearly 1 meter away from coherent sources, a screen is arranged. On the screen, interference pattern is obtained. Let us consider nth bright fringe is produced at the point P on the screen. Let capital D be the distance between coherent sources and the screen. Let us draw the normal to the paths from S1 and S2 to P. So the waves from S1 reaches at P along the path S1P, and the wave from S2 reach at P along the path S2P. Let S1N be the normal drawn to the paths S1P and S2P. Beyond the normal, we just imagine the paths are same, that is S1P equal to NP. So what is the path difference between S2P and S1P, path difference will be S2P minus S1P, which is equal to S2N. We know between the slits there is a distance small d. The plane passing through the slits S1 and S2 and the normal makes an angle theta. Similarly, D and the distance from the slits to P as MP. Let this point almost at the middle of the two slits, the point is M, so that MP and MN are normal. Or S1, S2 and MQ are normal. So between S1, S2 and S1N, angle is theta. Between their perpendiculars, the angle must be theta. Now we take an approximation that the distance D is extremely smaller compared to capital D. P is very close to Q, or QP is negligible distance. Hence, the distance S1P equal to NP. So we write the distance S1P equal to NP. Now from triangle S1, S2, N, what is tan theta? Tan theta equal to S2N divided by S1, S2. Let us call this as equation number 1. Similarly, from the triangle QMP, what is tan theta? Tan theta equal to QMP, that is PQ divided by MP. We just take an approximation that P is closer to Q. Hence, MP is approximately equal to MQ. Therefore, tan theta equal to PQ divided by MQ. Let us call this equation number 2. Now for both the equations, LHS is tan theta. So let us equate RHS. And RHS is S2N divided by S1, S2, which is equal to PQ divided by MQ. And what is this S2N? That is the path difference between the waves from S1 and S2 to P. S1, S2, that is small d. PQ, that is the distance of the nth bright fringe from the center of the screen Q. Let us call this distance to be x. So PQ is x and MP is equal to MQ. That MQ is equal to capital D. Let us substitute. S2N is the path difference. That divided by small d equal to PQ, that is x, divided by MQ, which is capital D. S2N, which is equal to x small d by capital D. I'm calling this as equation number 3. For getting nth bright fringe, we know the path difference between the waves must be n lambda if lambda is the wavelength of light. So according to the condition of interference, n lambda equal to x small d by capital D, which is equation number 4. Now just imagine n plus first bright fringe is formed at the point R, and let x dashed be the distance of n plus first bright fringe from Q. So for n plus first bright fringe, let us write the equation as n plus 1 lambda, distance is not x, it is x dashed. X dash, small d remains same, capital D is also same. So let us call this equation number 5. Just subtract 4 from 5. Equation 5 minus equation 4. What will you get? N plus 1 lambda minus n lambda, which is equal to lambda. That is equal to x dash minus x into small d by capital D. And what is x dash minus x? X dash minus x is the distance between n plus first bright fringe and nth bright fringe, which is termed as fringe width beta, which is equal to lambda capital D by small d. So what is fringe width beta? Fringe width beta is directly proportional to wavelength lambda, distance of the screen from the coherent sources, but beta is inversely proportional to the distance between coherent sources. So this is the expression for fringe width beta.